This is the Radio Shack Pro-2004 VHF-UHF scanner. This thing came out about the year 1986. I found this little gem at a local thrift shop, and I still have the price tag on it there. $1.99 as is. And of course, you know, as is means that it's broken, and sure enough it was. I took it home and it was completely dead. I then spent an enormous amount of time troubleshooting and repairing this thing. So if you come across a similar situation, I can maybe give you some pointers as to how to deal with this machine. Now, the first question you would ask yourself, of course, is why would you even bother with an old analog scanner? Sometimes these are called police scanners. People purchase them mostly to listen to emergency services like police and fire and EMS and so forth. Well, here in the US, all emergency services have moved to digital trunked radio, so that is completely gone. You can't listen to that anymore. So the utility of these machines is greatly diminished. But I decided I would try to bring it back to life. In retrospect, I kind of wish I'd never encountered this machine. The amount of time I put into it was just terrible. I will just tell you right now, the biggest problem is the solder joints. This thing has the worst quality solder, and that was what caused 90% of the problems. Now, the first problem with this machine is the display itself, specifically the backlight. The backlight for this display is an electroluminescent panel, and it wears out with time. Now, this machine is now over 30 years old. When I got this, the backlight was putting out virtually no light at all. And I did replace this electroluminescent backlight, and I made a separate video on how to do that. Now, I'm going to take this machine apart and show you what to expect. Now, the first thing is, we'll flip it over. There are these 4 foot pads right here, these 4 cushioned foot pads. You do not need to remove these. Just leave those on. You don't have to unscrew them. Those attach to the outer can here. They don't connect to anything internally, so you can forget those. Now we go to the back, and we have 4 screws. 1, 2, 3, and 4. And these 4 screws are holding on this entire outer can. And we just remove those 4 screws, and we can gain access. We will do that now. Okay, with those 4 screws removed, we can now remove this surrounding metal shroud. You just sort of push like so, and off it comes. Now, one of the things to be aware of in this machine, it has 2 ways in which you can power it. There is an AC line. Okay, so you can plug it into the wall. But also, conveniently, they provided us with a second input. And this is labeled 13.8 volts DC. And if you have an external power supply, you can run it off of that. And I happen to have this. I think they did this so you could power it from your car. You can get a cigarette lighter type power connector, so you could use it in your automobile. So I actually found this quite useful because I did have problems with the internal power supply. So for a while I was using an external power supply brick. Directly in our way here now is the speaker, which is held on by these 3 screws. It's blocking our access to a lot of the electronics, so we'll go ahead and we shall remove this speaker. Now this just lifts out, and it is connected to the main board. Now, when I was troubleshooting, I would use something to just sort of prop it up so I could have sound when I was troubleshooting. Otherwise, this isn't quite long enough. You're going to start tugging on it. These wires are really very thin, and they are easily broken. Now, I'm just going to remove this altogether. It's just a little simple connector. I'll just remove that and get that out of the way. Now we can now see a lot of the electronics here. But in order to gain access to troubleshoot, we're going to have to tilt up this front display and get it out of the way. It's held on with 4 countersunk screws. Here's 2 on this side and there's 2 on the other side. We'll go ahead and remove those. Now with those 4 screws out of the way, you can tilt this front face upward, and now you've got access to these electronics. Now you can see there are some metal cans, for electromagnetic noise abatement. Now this can you'll probably need to remove in your troubleshooting because there's a lot of problems that develop here. I'm going to go ahead and pop this off. And now we have a better look. One thing I should mention that is very important. One of the good things about this scanner is both the user manual and the service manual are available online. You can get them both at manuallib.com, and I will include a URL to where you can get those. In order to gain access to the underside of the board, we shall move to the back of the machine now. There are a few things we need to take care of back here. There are 2 little screws here and here which have to come off in order to get access to the underside of this circuit board. Underneath this panel is a backup battery. This battery keeps the memory alive, so you can maintain the memory of all the frequencies that you've programmed in when the power is turned off or it's unplugged. This battery holder does sort of gets in the way, and it's tethered with these wires, so probably you're going to want to unscrew this thing in order to mobilize it. So first I'm going to remove the panel, and there it is, standard 9-volt battery. Now I'm going to remove these 2 screws which actually hold the battery holder in place. Now this battery holder is mobilized, gives us a little more room to work. Now this main circuit board here, which is where most of the problems were, we have these 2 big transistors here and here, which are involved with producing power supply voltages, and they are screwed onto a little heat sink. We will go ahead and unscrew those. I shall get that heat sink out of the way. Now these transistors are no longer connected to the heatsink. Now when I was troubleshooting it, I often had to have the power on, and they did get quite hot, but they didn't fail, fortunately. Now the main board itself is held on with 8 screws. 1, 2, 3, 4, 5, 6, 7, 8. And we shall go ahead and remove those now. Now with all of the screws removed, we can now mobilize this board. And we can tilt this board up. I took a piece of tape and I connected the battery to the battery holder so it doesn't flop all over the place. And now we can expose the underside of this board. Here was the biggest problem with this machine. It was the solder itself. I don't understand exactly what is going on, but what I found were just numerous failed solder joints, particularly what you would call through-the-hole solder joints. You see these solder traces come down and they just sort of terminate. What they do is the solder continues through the board, and then it joins up with a circuit trace on the other side. I'm not sure why, but just many of those had failed. There was no conduction from one side of the board to the other. And I found myself just resoldering lots and lots of these. They're like all over the place, and so many of them had failed. I don't really understand why. Maybe there was something intrinsically wrong with the solder. Perhaps they were soldered at too low of a temperature. Maybe they were cold solder joints all along, and with the oxidation of the solder over time, they eventually lost conduction. I don't know. In some cases also, component leads also the solder had failed. But the point is, I just spent hours and hours and hours and hours just hunting these down one by one by one by one. It was crazy how much time I wasted on this thing. Finally, what I did is I just looked for every single one of these through the hole solder joints and just resoldered, just empirically. I just stopped ohming them out, and I just started resoldering just every one I could find. Now, in some instances, there are components on the other side which had solder problems. Here, for example, is our full wave rectifier. The positive pin on this full wave rectifier had lost continuity with the circuit trace on this side of the board. And there was just no way, I just couldn't solder it. I couldn't get it to work. I finally ended up soldering in jumper wires. Here we have jumper wires, 3 of them that I had to solder in order to make the power supply work. So just very time consuming. Now the mystery is, how is it that there could be so many bad solder joints? I have to assume at some point this machine actually worked. I assume that when the original owner bought this thing, it must have worked. Usually when electronics fail, it's usually one thing. It's usually like one transistor goes bad or a fuse blows or something, and that takes out the whole device, and that's when people stop using them. But this thing had multiple failures. So I have to believe that the solder underwent some sort of an aging process. In other words, I will bet that this scanner failed decades ago. It probably failed, like 20 years ago. And then the guy stuck it in his attic or his basement, and it just sat there until he finally just dumped it off at the local Goodwill store. And in that 20-year time period, these solder joints are going bad one by one as the solder aged. So by the time I got this thing, it just had many failures. Even as I was working on it, solder joints would be going bad. In other words, I would get something working, I would get the thing partially working, and then it would fail. And I would troubleshoot and I'd find another bad solder joint. I would fix it, it would work again, and then it would fail again. Even as I'm troubleshooting it and fixing it, solder joints are going bad. So I don't have any faith that this thing is going to keep working. I've got it working right now, but I could turn this thing on a week from now and it's probably got another bad solder joint. So this is like the system board from hell. I've never seen anything like it in all the troubleshooting I've done over the years. I've never seen anything act like this. And the other thing to be really wary of in this machine, we have these wires, particularly this group of wires right here. This group of wires right here, they wrap around to the other side. And I will flip the machine over. Now with the machine turned over, we can see where those wires go. This is on the underside, and we have 2 more boards here. This is the CPU board. Okay, and underneath this EM shield is a microprocessor. And over here we have the phase lock loop board. We have got 5 connectors onto this CPU board. I'm going to go ahead and pop the top off of this board so we can see what's going on. Now this is the CPU. This is the brains that drives everything. And here's the memory chip that holds the frequencies that you programmed in. Now also this board also had lots and lots of bad solder joints. Again, particularly these through the hole joints, and you can see a bunch of them right here. They sort of terminate in nothing. There's a bunch of them here, a bunch of them here. I've ended up resoldering a whole bunch of these because they were losing signal everywhere. So this was also a very problematic board. I spent a lot of time troubleshooting that board. The CPU board is held on with 7 screws. 1, 2, 3, 4, 5, 6, 7. If you're going to troubleshoot this board and fix bad solder joints, you are going to need to mobilize that board, so you're going to have to unscrew all those screws. And I found I could usually work pretty well just by disconnecting these two cables right here and sort of folding the thing down. Another note. At first I tried to remove the bad solder from these through the hole connectors. I would heat it up and use a solder sucker to try to get the old solder out. Unfortunately, the circuit traces are not very good, and I ended up lifting pads on a number of occasions, so I abandoned that practice. And I would just simply put good solder on top of bad solder and hope it would mix and make a decent solder joint. So far that seems to have worked. These wires are very delicate. They're very thin, very delicate. So you don't want to be moving things around too much. I'm going to go ahead and flip it back right side up. So every time you're flipping this board up, trying to, troubleshoot something on the underside, every time you flip that thing up, every time you rotate it like that, you are flexing these wires here. And I ended up breaking multiple wires in the course of troubleshooting, these super thin little wires, and I ended up having to resolder them. That was also sort of driving me crazy. Something would stop working, something would fail, and then I would discover one of these wires was broken. But I had to do an awful lot of this flipping up and down because so many solder joints were bad. Now, one thing to take note of, these two chips here, these are IC1 and IC2 respectively. And these control an awful lot of these. These are responsible for, detecting and amplifying the AM and FM signals respectively. And you can get access to those pins from here, and I found that very useful in troubleshooting. One other thing to be aware of, if you look at the schematic, you can't see a fuse anywhere. There's no fuse that appears on the schematic, but I learned the hard way that in fact there is a fuse, and it lives inside of the main power transformer. Now, in my troubleshooting, I accidentally created a short circuit and I blew that fuse. After some troubleshooting, I realized that there was a fuse hiding inside of here. And you can replace that fuse, and I made a separate video on how to do that. Well, I put the radio back together again, and the squelch control had stopped working. So I had to take it apart again, and I found this little wire right here had broken loose. As I had mentioned earlier, these wires here are very delicate, and when you lift up that board, you flex these things and you tend to break them. This guy right here is broken from right there, so I'm going to have to strip that wire and resolder it back in. Okay, I now soldered that purple wire back on, just in time to discover some more broken wires. Here on the squelch control rheostat, both the red wire and the white wire are broken. And over here on the power volume control, a red wire is broken. Oh my goodness. Okay, we have to fix those now. I've resoldered those broken wires and I buttoned it back up, put it all back together. And it appears to be scanning normally. And the squelch control is working normally. So after way more work than I ever should have put into this thing, I finally have it running. So in summary, this is a very poorly constructed piece of equipment. The solder is terrible. Watch out for bad solder joints everywhere. A lot of the wires are very thin and easily broken. By just manipulating them, they'll just snap right off. So you may be chasing broken wires as well. This front panel is probably worn out. You may need to replace that. Good news is the service manual and the user manual are available online. But having gone through this, and given the very limited utility of an analog scanner, I would not do it a second time. This video is a cautionary tale, really, more than anything else. In my opinion, this thing is so hard to work on, and it's such little utility, I wouldn't even start. So if you encounter one of these and it's not working, I would just leave it alone and move on to something else. Okay, that's about it.